Hey guys, thanks for joining this tutorial. Today we're going to talk about arrays in Solidity. Arrays are reference types, which means they don't store the values directly. Instead, they hold the address where the value is stored. So if you assign one reference type to another, you're not creating a copy of the actual data. Instead, you're passing the address that points to the memory location that holds the actual data. And this also means the value of a reference type can be modified through different variables names that hold the same address. When you use a reference type, you also need to specify the location where the data is stored, except for state variables, which are always of type storage. In Solidity, we have three data locations for reference types: storage, memory, and calldata. For storage type variables, the data is stored permanently and available for the lifetime of the contract. By default, all state variables are stored on the storage data location. However, storing data permanently in the blockchain is quite expensive. Memory is a non-persistent data storage, and the data is only available during the function call. On the other hand, storing data in memory is relatively cheap. And finally, calldata is a special data location that is only available for function arguments. Calldata is even cheaper than memory, and it prevents data from being modified. Otherwise, calldata behaves exactly as memory. In Solidity, we can define dynamic and fixed size arrays. For a fixed size array, we need to specify the number of elements the array should contain. There is only one member function that is available for all array types, the length property, that returns the number of array elements. For dynamic storage arrays, we have some additional functions: push and pop. Push adds an element to the end of the array, and pop removes one element from the end of the array. Those functions are only available on storage arrays, not on memory arrays. We can also use array literals to assign values to the array. However, be careful. Storage is always pre-allocated during contract construction and cannot be created later on, for example during a function call. So if we define a storage array in a function, it needs to refer to an already existing storage array that was created during contract construction. When you declare an array as a public state variable, a getter is created automatically. However, the getter allows you to retrieve only one element at a time. So when you call the getter function, you also need to specify the index of the array element you want to return. As you already know, arrays are reference types, and when you assign between two reference types, you're passing an address that points to the corresponding data location instead of directly copying the data. So assignments between two storage arrays create a reference. Assignments between two memory arrays also create a reference. But assignments between a storage and a memory array create a copy. That's the exception to the rule. By the way, strings and bytes are also arrays. They're considered as dynamic arrays. Bytes are used for raw byte data, and strings are used for UTF-8 encoded data. So let's take a look at a code example in Remix. So here we have a very simple contract with two state variables: array 1, which is a dynamic array, and array 2, which is a fixed size array of two elements. And we also have a function testArray to test various array features. So in order to modify our state variables, we can, for example, change a specific array element. If we take array 1, for example, we want to change the value of element 0 from 1 to whatever, 5. We simply specify the index and the value. And on dynamic storage arrays, we can also use the push and the pop function in order to add a new element to the end of the array. You could say array 1 push, and we specify the value we would like to add to the end of the array. Whatever we have value 1, 2, 3, we add the value 4, and that's it. So however careful, the push and the pop function is only available for dynamic storage arrays. So we couldn't do something like, for example, array 2 push a new value, because array 2 is a fixed size array. So this will generate an error. Okay, the compiler indicates immediately. So we can compile the contract and deploy it. Initially, when we check at index 0, array 1 should give us the value 1. That's fine. When we run the function test array, we'll change the value for index 0 from 1 to 5, and we add an additional element at index 3. For example, if we check here 3, we'll get an error message because there is no third element. We only have 0, 1, 2. Let's give it a try. Okay, so the function reverts. Now we call the test array function. When we call now at position 3, okay, we get the value 4, the value we specified here. And the 0 element will no longer be 1, it will be 5. Great. Now let's take a look at fixed size memory arrays. In order to define a fixed array, we specify the data type. Let's say we make a fixed size array of 3 elements. We need to specify the memory keyword. And we call it, whatever, it should be array 3. And we can directly assign some values. For example, we can do something like, doesn't matter, 21, 22, 23. Okay, here we will have a problem. So we get an error. Why do we get an error? Because here we specify an array of type unsigned integer 256. However, when we look at the values here, those are all values of type unsigned integer 8. So in order to assign this to an array of type unsigned integer 256, uint is just an alias for 256, uint 256, we need to cast one of the elements. For example, we can cast the first element, and we no longer get the error message from the compiler. Okay, that's fine. We can also do something like, let's declare a new array. Let's make it an unsigned integer 8. Again, 3 elements. We always need to specify the data location. Now we're interested in memory arrays. Okay, let's call this array 4. And then later on in our code, we could assign various values. For example, array 4. The first element, index 0, just something like, for example, 1. Now we can also assign array 3 to array 1. In this case, we assign from a memory array to a storage array, which creates a copy. So all the values we provided here will be copied into array 1. However, if later on we change a value on array 3, it won't affect the values in our array 1. On the other hand, something like this is not possible. So this generates a compile error because we can't assign a storage array, a dynamic storage array, a dynamic array to a fixed size array. Now let's take a look at dynamic memory arrays. We define it in the same way. We simply won't specify a size for the array. We use the memory keyword. So this is array 5. And of course, we can assign another dynamic array, dynamic storage array, array 1. Now, if we change a value on our array 5, it won't affect the values which are in our array 1. So let's make it 10, for example. So what happens in our code? Initially, we assign to the first index the value 1, then we will launch the function, we change the value, and we change the value once again here. Here we create a copy. We take all the values from array 3, which are 21, 22, 23, and we copy it over to our dynamic storage array, array 1. So after this code, the first element of array 1 will be 21. Now we assign array 1 to array 5, but this doesn't create a reference, this creates a copy, because we assign from memory to storage array. So if we change the values on our array 5, it won't affect the values stored in array 1. So let's give it a try. We'll redeploy the contract. So when we call test array, and we check array 1, which initially is 1, it should show 21 and not 10. Let's give it a try. So now we call it, we change it here to 5, we change it here again, but we create a copy 21, and this won't affect the values on our array 1. Okay, we get 21 here. And finally, let's take a look at dynamic storage arrays. Now here we have to specify the storage keyword. Otherwise, it's the same declaration as with the dynamic memory array. And of course, we can assign our dynamic storage array, array 1. So what happens if we change a value from our array 7? So we set this, for example, to 8. Now, because we assign between storage and storage array, this assignment will also affect the value of array 1. So if we redeploy the contract, once again, we call test array, what happens? Okay, initially the value is 1 of the first element. We already know this. Here we set it to 5, here we create a copy, we set it to 21. This doesn't have any effect because it's an assignment from memory to storage. However, here it's an assignment from storage to storage, and here we change array 7, the first element, which will also affect the value of array 1. So after calling test array, we should get 8. Let's give it a try. We call test and we check the first element, index 0, and now we should get value 8 because we create a reference when we make an assignment from storage to storage. So what about doing something like this? We create a dynamic storage array and then we try to assign new values. For example, array 8, first value, and we assign, doesn't matter, whatever value. Now this would generate an error. Why? Because as we already learned, storage is always pre-allocated during contract construction and cannot be created later on. So if we define a storage array in a function, it needs to refer to an already existing storage array that was created during the contract construction, as we did here. But something like this is not possible. Well, that's it about arrays in Solidity. Thank you very much for watching, and I'll see you in the next tutorial.